All right. Good morning, afternoon, or evening, everybody. Welcome to the CSDA Vendor Focus Umbra NASA Commercial Satellite Data Acquisition Program training webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Saving Time, so we're going to go ahead and get started today. What I'd like to do first is begin with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. But if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A panel rather than the chat, and you should see that located on the right side of your screen. If you don't see the Q&A panel, click on the three dots at the bottom right portion of your screen, and that will pull up your panel options, and you can insert a check mark next to the Q&A option. A quick word about the chat. Participants will have the capability to chat with hosts and presenters, but not with all participants. So again, if you have any questions, please enter them into the Q&A panel on the right side of your screen. Today's webinar is being recorded. The recording will be made available online within a week of completion. Once completed, what I will do is I'll send an email to all registrants and participants that includes links to both the recording and presentation slide decks used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and demonstration, and then a 15-minute Q&A period will follow. And then depending on the volume of questions we receive, we may extend the Q&A session, but we will have a hard cutoff of 3:15 p.m. Eastern Time. During this afternoon's webinar, we will have one speaker from NASA's CSDA program and two speakers. Let me pull that slide up here. From program vendor Umbra. Our first speaker this afternoon is Dana Ostrenga. Dana is the CSDA project manager here at NASA's Goddard Space Flight Center. She's going to kick us off this afternoon with an introduction to NASA's CSDA program and its objectives, and provide a high-level overview of Umbra, the Umbra IDIQ contract, and data access. Once finished, we will then transition to our Umbra vendor speakers. Our first speaker from Umbra is Omar Wheatley. Omar is the Strategic Director of Programs at Umbra and will kick us off with the vendor portion of today's event. He's going to introduce the company and also provide a program overview. Once finished, we will transition to our second vendor speaker, Kyle McLeod. Kyle is the Customer Engagement Manager at Umbra and will continue today's content with an overview of the CSDA products, the Umbra-specific CSDA products, research use cases, and data and delayed delivery, to include information about the Canopy proprietary data discovery and data access application. Once Kyle has finished with his presentation, he's going to toss it back over to me for the final optional polling questions. And then from there, we're going to transition directly to the question and answer period. Before I toss it over to Dana, I'd just like to say a few words about this afternoon's Q&A session. We will have two Umbra subject matter experts joining us. We've got Eric Steinbach and then also Chris Brown. We'll try to answer all of your questions within the time allotted, but if we're not able to address your question during the Q&A period, our speakers will be able to follow up with you offline. And so with that, it is my pleasure to introduce today's first speaker, Dana Ostrenga.
Thanks, Jennifer, for getting us started today. Welcome again all to the Commercial Satellite Data Acquisition Program webinar series, where we're here today to learn about Umbra. I am Dana Ostrenga, the CSDA Project Manager at NASA Goddard Space Flight Center. So let's get started with why buy commercial data. The commercial satellite industry has been rapidly growing, especially in the area of Earth observation. Commercial Earth observation satellite systems have been developing at faster rates, and ever-increasing numbers are being added to their constellations. They're leveraging newer technology, providing higher spatial resolution and shorter revisit rates, and they're really making it ideal to augment our existing government satellite data. So how does NASA fit into all this? Well, NASA has a really strong history of Earth observation data acquisition. We acquire, enhance, utilize, and steward that data, and NASA really wanted to explore the possibilities of acquiring and integrating commercial data into our broader suite of data to support research and application initiatives. I'll go into the evaluation portion of our program a little bit later, but process really provides an assessment back to the commercial partners, which improves the interoperability and accuracy of the data, not only for marketability, but easier to integration into our research programs and our applications that we use. If you missed any of our previous webinars, just to give you a little bit of background about the CSDA program, it really serves as a central mechanism at NASA for identifying, evaluating, and acquiring commercial satellite data that supports NASA's Earth science research and application goals. The program has 5 main goals. One is to establish a continuous and repeatable process to on-ramp new commercial data vendors to our contract. Another is to enable sustained use of that data for broader dissemination to our scientific community. We also want to ensure long-term data preservation, access, and distribution of that data that's acquired to ensure scientific reproducibility. We want to collaborate and partner with our agency, other federal agencies and international partners on the evaluation and scientific use of the data. And we want to comply with the 2003 U.S. Commercial Remote Sensing Policy. If you can go to our CSDA YouTube channel to see our kickoff webinar for the series, talking more about the program, as well as a list of all of our commercial partner webinars to date. This slide showcases our diverse array of commercial vendors, each providing unique satellite data products to help NASA advance Earth science. We currently have 15 commercial vendors on contract that we can acquire data from. For multispectral imagery, we partner with Maxar, Blackbear, and Satellogic. Planet operates in both the multispectral and hyperspectral domains, alongside with Teledyne Brown Engineering and Pixel, who specialize in hyperspectral data. In the area of synthetic aperture radar, we work with MDA, Umbra, ISI, Capella Space, and Airbus, enabling all weather and day-night imaging. For monitoring methane emissions, we go to our provider, GHDSat. GNSS radio occultation capabilities come from Planet IQ and Spire, contributing to the valuable atmospheric profiles. And digital elevation models are sourced from Maxar and Airbus. And for precipitation radar, we utilize data from Tomorrow.io. Together, all these vendors really enable NASA to access high-value commercial satellite data across a broad range of Earth science applications, enhancing our ability to monitor and understand our planet. When NASA evaluates commercial data, it provides confidence not only for our scientific community, but really also for the commercial vendors themselves. So I just want to highlight some of these benefits. First, vendors gain greater recognition within the science and application communities. Being evaluated by NASA really signals a credibility. Second, it builds trust. So with customers, investors, and partners, by showing that the data meets rigorous NASA standards. Vendors also gain access to NASA's deep expertise and data quality, which can strengthen their product and practices. And these evaluations often provide vendor capabilities, boosting like their staffing morale and help retain skilled teams. Through CSDA communications, vendors are also will see increased in awareness and visibility throughout the research ecosystem. And finally, NASA evaluations really bring greater exposure to the full utility of the data, so ensuring that it's used to its maximum potential. Really, that evaluation process not only ensures the scientific community of the data quality, but it also directly strengthens vendor credibility, capabilities, and visibility across that research community. Since that evaluation process plays such a critical role in our program, I just want to walk you through the data evaluation criteria that's part of the process when assessing the quality and utility of the data. So first, we look at how easy it is for researchers to search, discover, and download data from the vendor systems. And if access is difficult, it limits scientific use. So that's why it's important. Second, we evaluate the completeness and accuracy of the metadata. The metadata provides the context scientists need to properly interpret and apply the data. Then we assess vendor support services, responsiveness, availability, and technical expertise. That strong support helps researchers resolve issues quickly. Further, we consider the usefulness of the data for advancing Earth science. Does it really align with NASA's science objectives and help fill important gaps? And finally, we evaluate the quality of the data itself, like things like geolocation accuracy, radiometric accuracy, and calibration. And we use that ESA NASA evaluation guideline. I'll get there in a moment. So together with all these criteria, we really ensure that NASA when it brings in commercial data, it's not only high quality, but it's also accessible, well supported, and it's able to deliver real value to the science community. So I mentioned the NASA guidelines as used part of our evaluation process. NASA and ESA partnered to build a joint quality assessment framework to give confidence in commercial Earth observation data. ESA first developed a mission quality framework, and NASA CSDA program expanded it to evaluate both data quality and how well it supports research application. Together, this framework sets consistent guidelines for calibration, geometric accuracy, metadata, and validation. It helps ensure that NASA can make confident acquisition decisions, really strengthens the vendor accountability, and it reinforces that NASA-ESA partnership. All new business is on-ramped via indefinite delivery, indefinite quantity process. Just want to talk a little bit more about this and the program highlights that's been going on in the last year. So all new business is through IDIQ. Vendors compete for task orders under 3 license tiers: a public release, U.S. Federal Government Plus, and other U.S. federal government. NASA will not prohibit the use of data as long as it abides by those EULAs. We're also integrating CSDA acquired data into NASA's Earth Data Search. This will make commercial data more discoverable and usable alongside our current NASA mission data. And we're strengthening our collaboration across the U.S. government by coordinating purchases, sharing evaluation outcomes, and aligning our data requirements. And internationally, we continue working with partner ESA on developing guidelines, evaluation methods, and programmatic processes. CSD is really focused on expanding vendor participation, improving access to commercial data, and building strong partnerships to maximize the value of commercial Earth observation data. So now that brings me to the CSDA Umbra partnership. In October 2023, CSDA awarded Umbra an IDIQ contract under our first RFP solicitation. Through this effort, we launched a ROSA solicitation for principal investigators so that they could assess the utility of the data for science. Our CSDA subject matter experts are now working with technical teams and PIs to evaluate the data and better understand Umbra's constellation. The evaluation results will be briefed to headquarters and the vendor in September timeframe, with the SME quality assessment report and the utility evaluation full report being released sometime in late fall. Download of the data is being prepared for release through the CSDA Satellite Data Explorer, or we call it the SDX, alongside with the evaluation report. So if you want to see further the outcomes of those evaluation reports, they will be released to the general public. If you qualify for data access under our EULAs, you can register for access on the CSDA website. The Satellite Data Explorer, SDX, provides a central web interface for search, discovery, and distribution of all of our CSDA data. This really ensures easier access for researchers and smoother integration with other NASA data systems. The data that is downloaded will continue to be integrated and available through this interface, and as I mentioned previously, it is also being added to the Earth Data Search client. That brings us to the next portion of our webinar, so please welcome again our invited speakers who will talk to you more about Umbra. I'll stop presenting, and Omar, then you can tell us further more about Umbra's system.
Great, thank you. Thank you, Dana. And while Jules is getting our slides put up there, first I'd like to just say thank you to Jennifer for getting us all prepared for today's event. We're very excited to be here and talk a little bit about our company and our products. And thank you, Dana, of course, for the kind introduction to us on the CSDA program. We're very thrilled and honored to be part of this program and look forward to continuing to contribute to the NASA science mission. So what we'll cover today is just I'll do the commercial part at the very beginning, talk a little bit about Umbra, kind of our principles, how what we're about, talk a little bit about our satellites and constellation, brief touch on the program overview. Won't have to cover too much from based on Dana's introduction, and then I'll hand it over to Kyle, who will go into more depth of the products that are on the CSDA contract, talk a little bit about their use cases and how we deliver data to our customers. So we can go to the next one. So yeah, who are we? So Umbra is 100% U.S. owned and operated space technology company, and we deliver advanced systems from sensors to spacecraft that empower customers worldwide with unmatched access to high-resolution radar data from space. Using our first principles engineering and end-to-end system ownership and rapid satellite customization, Umbra supports critical missions that deliver information advantages, redefining what is possible in and through space. So what we're as we're redefining what's possible, we're expanding access, increasing persistence. We're delivering a powerful information advantage to our customers. So from the ground up, using first principles engineering, we design, build, test, and we operate our systems. And engineering, and we engineer novel solutions tailored to the missions that matter most to our customers. Actually, you can go back one. Sorry. Our Agile SAR constellation is the most capable on the market. We produce the highest quality imaging data through any weather, day or night. That's one of the big advantages of synthetic aperture radar. And as a result, we're empowering customers through our data access with persistent access, resilient performance, and proven results on orbit. So our commitment to these first principles engineering has fueled year-over-year performance and growth since we entered the market in 2021. And then together, these capabilities make us the most effective partner, we believe, delivering the flexibility, performance, and resilience to meet our customer mission demands. So yeah, we're constantly redefining our technology and our products and our craft moving forward. So let's talk about our leadership real quick. So I wanted to just highlight just the leadership team from primarily on the remote sensing side, all the way up to the top. So David Langen, he's our CEO. He started the company based on this idea of redefining how we do space through, and especially through remote sensing. And he's assembled an amazing team of engineers, was super passionate. It's kind of like the most extroverted engineers you'll ever meet on the planet. They're great people, and so talk to us, and we'll share our enthusiasm and everything. So that's just want to give you a snapshot of our team there, and little me on the right. But very thrilled to be working on this team, and we're thrilled to support our customers. Next. So we're divided into 3 business units. So starting with the remote sensing, we deliver the data. So we're focused on delivering the highest quality data at volume, that's reliable and resilient, and deliver it fast to our customers. That's our main focus in remote sensing. On the mission solution side, that group is designed on the actual platform. So certain customers may have unique mission needs that will build systems to go support them. So so we can build them entire satellite systems to meet their need. And as a result of the fact that we build our own satellites, we build our own components, we're a vertically integrated engineering company. We've also just recently opened our space systems business unit. I think that was actually, we launched it a week and a half ago, where we will also be selling flight proven components, for others as they build their system. So that's really, that's the 3 sections of our company. Go on the next one. And then where are we located? Our main headquarters is located in Santa Barbara, and that's where you're going to find most of our corporate services. That's where the engineering and the actual manufacturing of our satellites occurs. And then the East office, Umbra East, here in Arlington, Virginia, we started about 3 years ago, actually almost 4 years ago over here. And primarily this is where our programs are housed. We have a group of engineering and other corporate services here, and government relations. So we're across the country. We've launched from both sides of the country, and we do have a fairly sizable remote employees as well. But that's the 2 areas that's our 2 main hubs. Next. So let's talk about our satellites and our constellation. So here's a picture. Here's an image of what our satellite looks like. It's hard to really look at the scale here, but if you can imagine, if I folded up that antenna and the secondary, which is the one sticking out, and then the parabolic dish, and I folded that up, it would literally fit on your desk. And this enables us to be launched on rideshare missions, where they can carry multiple small sats alongside. It's about 100 kilogram satellite, and it is yeah. You can go to the next one. And so it's definitely evolved over time, and our capabilities. So we have a license that allows us to operate at 1200 megahertz, and that's what enables our our highest resolution products. And the system is designed to be able to collect in volumes and slew, and really was designed as a really high quality point collector. And this slide is here to show you that how progress is made in a way, and trying to paint a picture with paint 1,000 words with a couple pictures here. We started where we did, first principles engineering, and through continuous improvement and evolution of our technology and our capabilities, you can see where we are today. So that's us, and now we're just getting started. And that's just a highlight of growth over a couple of years. So we've launched 10 satellites since 2021. We continue to grow the constellation. We have launches planned we have a couple of satellites launching within the next 6 months, and continuing to grow to meet the growing demand that's out there. We build our satellites in the United States. All the parts are built here. And while we don't have the largest commercial constellation on orbit, we do have a lot of access. We have really high access and rapid access to areas of interest globally. And, delivering at scale allows us to drive real operational outcomes and at speed. Next. So really, so I mentioned remote sensing, we're about delivering the data. So our tenets are, we deliver high volumes of data at high quality, at high speed, and with high reliability. So we can deliver, and I apologize for the small font on this slide, but we deliver really high volumes due to the agility of our satellite and the access that we're able to get on the ground. As I mentioned, we offer the highest resolution commercially available. Our system is actually designed to deliver less than 25 centimeters, but currently our products are at the 25 centimeter resolution. We obviously care about the protection of data for our customers, so we encrypt our data to make sure that when we collect and downlink, that we keep it secure. And we're always pushing the limit on the speed, because usually when people need SAR data or any sort of ISR data, they need it fast, because things are happening in the world, things are evolving very quickly, and speed matters. So we're always trying to push. We're constantly on the drive to push the limit on how fast we can deliver our data. So Kyle's going to talk a little bit more about our products, but our spotlights, we have 5x5 spotlights, imagery, and all these different resolutions capable. We have different modes that we can operate those in, and then there's a list of the products there. Probably hard to read there, but we deliver the product, varying products based on different customer needs. So we have U.S. government customers who use certain formats, and then there's commercial standard products that people tend to go after as well. And Kyle will talk a little bit about that. Thanks. Next slide. Okay. So then why Umbra? So really, the advantage that we provide our customers is that we see what, where, and when others cannot. We, as I talked about the high volumes, we have the flexible models. We offer the ability for the customers to task our satellites. You literally can put in the parameters. They can task directly what they need, and then it gets on our schedule and it gets delivered. But we can also do custom tasking if there's like special needs. And so we're there to help to support our customers. And then lastly, really, our business model is driven off of unit economics. So we think that's very important when delivering SAR data to the commercial market, because through vertical integration, we have more control over how we build it. Allows us to build our satellites at low costs. We can deliver the data in high volumes of data, and we also add in there permissive licensing. And I know Dana talked about the licensing on the contract, but from a commercial standpoint, our commercial standard for licensing is Creative Commons CC by 4, which basically allows our users to take our data and do whatever they want with it, as long as they give us credit. They can sell it, they can reprocess it, they can do anything they want with the data. And as a result of that, of the vertical integration, our low cost of satellites, our ability to deliver at scale, and make it very easy for our customers, that allows us to do really have the lowest pricing on the market, so that we can really flood the market with SAR, so that people can go solve the problems that that they know can be solved with SAR, and also figure out what else they can go solve with SAR data. So that's really what we're built around. So program overview, this part's really short because Dana, thank you. You did a great job. But we are super excited to be part of the NASA CSDA program. We love the fact that we're doing science missions for the government. And, it's, we believe that we're adding to that ecosystem of commercial and how it can augment the government's collection capabilities. And as was mentioned, we joined CSDA on October 2023 on this contract. And, as Dana mentioned, we're on an evaluation task order, and we're very much looking forward to the feedback and the quality assessment coming this fall. And then just a couple of snapshots here, but I'm not going to steal Kyle's thunder here. But there's multiple areas that science applications where SAR can be used. So really delivering impact through commercial data. And then mention the licenses. I wanted to just cover a little bit here because the EULAs. This is just our short description of how the EULAs work that Dana mentioned. There's the 3 that are on the contract. So I mentioned CC by 4 earlier only because we don't charge an uplift for increasingly permissive EULAs. Some providers may do that, but because CC by 4 is our commercial license and it's about as permissive as it gets, then it makes it very easy for the government to order our data at their EULAs. And then as I mentioned, you can order data through our Canopy platform as a self-service, or we can assist with custom tasking. So I'm not going to go into detail on the products. That'll be for Kyle. But that's what's on our contract. And with that, I will turn it over to my esteemed colleague, Kyle. Thank you very much.
Thanks, Omar. I appreciate it. Like Jennifer mentioned earlier, my name is Kyle McLeod. I'm the Customer Engagement Manager here at Umbra for the remote sensing portfolio. Prior to coming to Umbra, I spent nearly 20 years as an imagery analyst supporting the Department of Defense. We're going to go over some of our products that are available not only through CSDA, but also in the commercial sector. The first being our Spotlight imagery. I believe most users will be familiar with Spotlight. But Umbra offers the highest resolution Spotlight imagery currently on the commercial marketplace, which enables the most detailed SAR analysis possible. As Omar mentioned previously, our Creative Commons licensing means that our imagery and any of the analytic products that result from the imagery can be shared broadly without any concern. I'm sure you've seen some of our customers and some of our partners posting their analytic products on Twitter and LinkedIn. And we always appreciate that. The commercial imagery world is slowly but surely, expanding and letting the general populace know what is happening kind of behind the scenes globally. Additionally, Umbra's flexibility allows the user to choose resolution, azimuth angle, grays, and many other collection parameters, which enables very precise scientific investigations. Next slide. This is an example of that Spotlight imagery. Again, there's the next product we'll talk about will be our long dwell Spotlight. The long dwell Spotlight is a dwell image which is a transmit for a longer period of time over an area. The long dwell produces a higher quality than other systems due to our agile spacecraft and the ability to steer the aircraft as we are on the area of interest. And again, the flexibility here allows users to choose resolution, looks, azimuth, and all of those things for your investigations. Next slide. Looking at the long dwell and what it unlocks, you can see in this image being having a lot of different topography. You have the mountains and the ocean and the city. It really unlocks a lot of different aspects of analysis to include, urban mapping. The high resolution allows, reduced speckling. Because it's an ocean scene here, it is also usable for vessel tracking, to include, depending on your processing as a customer, heading and speed estimation, including classification via the wakes happening on the ocean surface, the water surface. Additionally, looking at the topographic analysis is possible. Just in this one image, again, you can see the mountains there. This is open up, slope roughness and delineation, terrain segmentation, things of that sort. All right, next slide. The next product we'll discuss, and all these are in our spotlight kind of portfolio, is our extended dwell. Extended dwell is an even more advanced variant of our spotlight SAR, in which our satellite maintains the radar focus on a fixed area for upwards of about 25 seconds, whereas a normal spotlight image is going to maintain that fixed ground focus for between 1 and 10 seconds. What this does, again, is it maximizes minimizes the speckle noise and enhances the interpretability of the image. Through this, we're able to observe the same location from a myriad of different geometries as the satellite passes over, which opens up even more capability for an analyst and for a researcher. Umbra is unique in the market that we're able to provide this level of quality at upwards of 25 centimeters in an extended dwell. Slide. And then looking at another example, you see a lot of ocean and shoreline images, but with the extended dwell, it's going to be valuable for opening up missions like maritime domain awareness, energy and infrastructure monitoring, port activity observation if you're looking at the activity in ports. Additionally, it is useful in helping determine where there might be object boundaries and where they need to be cleared, even in shadowed or cluttered scenes. And then additionally looking at structural detail in the built environments and using the distinctive scattering patterns of man-made objects to delineate those from natural-made materials. Next slide. I think the last product that is on contract that we'll discuss will be our modified Stripmap. Umbra's modified Stripmap was first delivered exclusively to NASA via the CSDA program. Our product is unique in the commercial SAR world because we are not limited to imaging just along the ground track. Our dynamic Stripmap allows collection from various angles from 0 to 360 at high resolutions. Currently on the CSDA contract, we're imaging at 2-meter resolution. However, we anticipate that our modified Stripmap offering will be released to all customers by the fourth quarter 2025 at even higher resolutions than the 2-meter resolution. Next slide. As an example of that modified Stripmap, and it illustrates key strengths of our product, including the high resolution, being able to scan at any in any direction, as we're not limited to that a long track imaging. Some of the great use cases for this are going to be any area where you need wide coverage, in particular maritime domain awareness, border monitoring, coastline analysis, as well as things like infrastructure and corridor monitoring. Next slide. Some of the research and use cases that we've seen, and one that is close to my heart, is the polar monitoring. All of our satellites currently are in a polar orbit. We do anticipate with customer demand, we would put some satellites in a different orbit, but currently they're all in polar orbit. We've worked extensively with Dr. Fretwell out of the United Kingdom, and also with Dr. Michelle LaRue out of New Zealand, in monitoring the ice flows in the Ross Sea in Antarctica, as well as the penguin populations as the environment changes in the Antarctic region. And I anticipate working with Dr. LaRue. There should be a paper coming out this year highlighting the utility of Umbra synthetic aperture radar in identifying the penguin colonies in the Antarctic winters. Next slide. The next use case we'll kind of highlight will be disaster response. The image on the left highlighting the Los Angeles fire destruction this past year. Additionally, NASA's disasters program, in collaboration with the Earth Science Mission, finds utility in synthetic aperture radar, as many times when disasters are happening, they're either weather disasters, in which electro-optical imagery can't see through the clouds, or they're happening at night, again making it difficult to utilize things like electro-optical imagery. Some of the specific use cases beyond the wildfires would be hazard monitoring, infrastructure response, evacuation planning, as well as looking at things like slope stability. We routinely observe after wildfires, if there's any sort of precipitation afterwards, those hillsides and those slopes deteriorating and causing landslides. Beyond that, you can help synthetic aperture radar using change detection algorithms can be useful in helping identify when the slopes are failing and terrain that might be at risk in near real time. And then the last example we have on this slide is talking about volcanic activity monitoring. We don't have a picture for it, but late last year, we were helping observe the Icelandic volcano that was erupting, monitoring both the lava flow and as well as the ice deterioration on the coast there. Next slide. All right, we're going to talk about order and delivery. Umbra has taken great strides to make sure that ordering imagery is very simple. And in that, we have developed what we call our Canopy user interface. We've made, it's very flexible in tasking. We have standard processing, so any of the standard image processing that you're used to, you will have available via our system. And then we have some optional formattings that include CPHDs, which are something of raw format. Lastly, we have a very robust document library that makes utilizing Canopy as well as our APIs super simple. Next slide. We'll spend the next couple slides discussing the Canopy UI. Again, as you can see, this is a very simple setup, but as Omar had mentioned previously as well, while this is a simple to use user interface, we also give you, the customer, as much leeway as possible, because at the end of the day, you know your mission better than we do. So we allow you to choose your tasking modes. We allow you to choose your location, either by clicking on the map or inserting your longitude and latitude. Additionally, we allow you to choose your resolution, anywhere from 1 meter resolution being our lowest offered right now, all the way up to 25 centimeter resolution. And then we allow you to choose the dwell product, a number of multi-looks that you need for your product. But again, we trust that you, the analyst, that you, the consumer, are able to best determine what you need to suit your mission. On scene size, we currently offer for Spotlight 5 by 5 kilometers. Additionally, we do offer what we call a natural footprint image, which is just going to give you more area at that higher resolution. And then in fourth quarter this year, when we roll out that scan mode or Stripmap mode, that's going to give you an even wider swath to accomplish your mission. And then at the end, you can see the 7-day cycle. Our scheduler currently runs on and allows you to see feasibility on our whole constellation 7 days out, allowing you a lot of flexibility to plan your collections and plan your mission around our constellation. Next slide. And this is showing kind of a zoomed in view. We won't go in super detail on all of the tasking parameters with Canopy. But again, this is kind of showing that zoomed in view. Anything within that blue circle, we guarantee will be in your 5 by 5 kilometer bounding box. Additionally, if you are more of an advanced user and want to plug this into your own interfaces, we have very robust API integration, as well as being able to do some custom tasking on our end, utilizing our collection optimization team to really get the most out of our constellation for your given mission set. Next slide. And then the last piece I want to discuss is Umbra's open data program. We have definitely taken great strides to deliver thousands of images free to our open data program. What this allows is customers who might not quite be ready to purchase data from a company like Umbra to go in, observe the imagery, find out what resolutions, what look angles, what multi-looks might best suit your mission needs. Again, without having to ever purchase anything. It also allows you to develop your technology on our imagery before committing to those purchases. We're continuing to upgrade our interfaces and our content. We're adding new content just about every week to our open data program. Next slide. And with that, I will turn it back over to Jennifer. Again, I want to thank you for coming out today, and thank you for having us.
Thank you so much, Kyle. Okay, with that, let me go ahead and open up the final polling question. And we will jump right in to the Q&A period. All right, so give me 1 second here. All right. Okay, now let me get to this thing opened. All right, you should all see the polls on the right side of your screen. And I do know that there were some questions that were posed in the chat. I'm actually going to start there. And thanks to those of you who also added them to the Q&A. That's wonderful because the chat is only being shared between participants and hosts and panelists. And so we definitely want for everyone to benefit from these questions. So I really appreciate all of you for that extra effort. Thank you. All right. So the first question is, and again, this might have already been added to the Q&A, but I'm going to start here anyway. Could you explain how Umbra active tasking works through CSDA?
I can take that one, everyone. So currently right now, what happens is you come through the CSDA program. We are soon to release a operational tasking request system that'll make this a lot easier. But right now you reach out directly to the program, you let us know your needs, and we will proceed from there with pursuing acquisition if we don't already have acquisition, or tasking if necessary. Not if necessary. Tasking if we have the acquisition directly coordinated with Umbra. Once the operational tasking request system is released, you'll be able to do it directly through our UI, and then the approval goes through a quick approval process, and then the tasking will get scheduled.
Okay, well, perfect. Thank you, Dana. So the next question is the 5 by 5 kilometer the largest area coverage per image you can provide? There's actually 3 questions contained within this one. Okay, so is the 5 by 5 kilometer the largest area coverage per image you can provide? Width of the strip map swath? And can you guarantee INSAR viable repeat baselines?
So I can answer that. Currently for Spotlight, 5 by 5 is the baseline. We also offer a natural footprint image, which kind of expands that out. With that natural footprint, generally, you might see some quality degradation on the edges outside that 5 by 5. 5 by 5 is what we offer as the highest resolution possible. And with the strip map mode, we'll be advertising what those resolutions beyond the 2-meter resolution will be, and the swath lengths when we do commercialize that. I believe for the CSDA program, it is up to 100 kilometers on that 2-meter resolution.
Well, thank you so much, Kyle. Appreciate that. And as a follow-up with the same webinar participant, also, can you speak to the revisit time?
I can take this question for Umbra. So Chris Brown, Director of Collection Optimization here at Umbra. Revisit time is generally for an imaging opportunity about every 12 hours for any spot on Earth. Obviously that'll vary by latitude, so the higher latitudes have a much higher revisit time. And regarding the question on guaranteeing INSAR and viable repeat baselines, that's not something available today. If we have generally that only occurs accidentally or as it happens, but it's not something built into our current constellation.
Okay, well, thank you so much, Chris. I was just typing a quick response here. And as a follow-up to a earlier chat correspondent, this one is for Geek. You mean that the images are downloaded for free? My question was going to be, how much does it cost to acquire specific images?
Yeah, I made the mistake of responding in the Q&A and not waiting till the Q&A session, so my apology for that. Our imagery does have pricing associated with it. All of our pricing is fully transparent on our website. So you can go and search on Umbra Space pricing, and you will see the pricing of our various resolutions and looks and other products. So you can get a good sense of what you might need to budget for. As Kyle and Omar both mentioned, our licensing is very permissive. Creative Commons CC BY 4.0, which you can look up. We encourage you to use our data. We encourage you to share our data. We encourage you to collaborate with our data. All we want is that you give us attribution that you're using our data. You can read all about the Creative Commons license both on the Creative Commons website and on our Umbra terms of use page. While we don't give our data away for free, we do kind of give our data away for free. We were the first to create a large-scale open data program for SAR imagery, and we still have one of the largest commercial open data programs. We have one of the largest commercial high-resolution SAR open data repositories in the world. All of that data is available for you to search, discover, and download for free. And that same Creative Commons license comes along with that for you to share and collaborate with. So you can also find out more about our open data program on our website. And I know Kyle mentioned it in his presentation as well.
Okay, perfect. Okay, so the next question is, and I did just notice that there's another question in the chat, so I'll hop back up there in just a moment. Thank you for your question. If you could, add your questions to the Q&A panel, that's super helpful, and then all of our webinar participants can see the question. So the next question is, in this open science context, I'm curious if others are developing RTC, and if so, what DEM products are used which have appropriate resolution and do not drastically degrade Umbra resolution?
I can answer this one. I do not recall exactly which DIM we are using. We can work on getting that specific information to you. But currently, when we do provide DIM corrected data, what we do is we take the DIM, which has its native resolution, and then we upsample that resolution to match our image products. And that way we are not degrading our image products and still getting the best DIM possible over our data.
Well, that's excellent. Thank you, Eric. Appreciate your response there. Alrighty, we are going to move to the next question. Let's see here. I've seen some online information mentioning 16 centimeter products. Is that something that is available or will be?
Currently, while we're licensed and our system is capable of imaging down to 16 centimeters, it is not something we've commercialized yet. One of the reasons being a 16 centimeter SAR product is a very large data file. Even at 25 centimeters, some of our files can be a little bit robust for the average user. Currently, 25 centimeters is about the highest resolution we're going to offer on the commercial market.
All right. Well, thank you for that response there. I'm going to hop back up to the chat here. And again, it might be that the user has also added this question to the Q&A. And if so, then I will skip it when I get to that. Let's see here. So this kind of builds on the previous question regarding, do you provide the RTC products and what is the geolocation accuracy and what specific DEM data sets are used for geocorrection?
So I think this is a copy of the previous question. So
is it? I thought it was a little bit different. Okay, that's good. We can move on to the next. What are the ground sampling and accuracy assessment procedures?
So I'll take this one again. So to verify the ground sampling spacing that we provide as well as the accuracy of our geolocation, we regularly image a known point calibration array in Southeast Michigan. And then we verify using known GPS locations for all of those locations, our accuracy, and once again, looking at the IPR responses to verify our ground sample spacing. For our geo correction or for our geo accuracy, we usually have between 5 meter for a 90% error rate.
All right. Well, thank you so much. And I am just going to scoot down here. Sorry for the repeat question. Okay. Can you also speak to the polarization specifications?
I can answer this one as well. Our typical baseline tasking for polarization is vertical mode, but due to the ability to rotate our bus during operation, we can also collect horizontal polarizations during collections upon request. We are only a single pole system currently, so we are limited to single pole products.
All right. Thank you. I appreciate it. And then let's see here. Moving to the next question. Can you comment on the I'm not sure how this acronym should be pronounced, so forgive me on this, on the NESZ levels of your imagery and on calibration repeatability over multiple passes and satellites for those of us who are interested in absolute sigma zero values?
I can answer this one as well. Our NESZ levels are going to be dependent upon how the image is tasked. So depending on the geometry as well as the resolution that is requested, we will put a theoretical NESZ value into our metadata to report what is expected for that image product. We have verified these theoretical NESZ values as well as our calibration once again through those imaging opportunities that we've taken with the calibration or the point target arrays in Michigan. And using that data, we are able to calibrate our data products with repeatability, and we have that information as well in our metadata for use by anyone who wants it.
All right, excellent. Thank you. Making sure, and I will hop back up to the chat in just a moment. So moving on to the next question here. When considering the Umbra Historical Archive, are there any key moments when image quality improved? For instance, data collected after April 11th, 2024 has a significantly improved signal-to-noise ratio and so on.
That's a good question. I don't think there's one date I can give you where, you know, if you're interested in one particular aspect, you want to look before or after a certain date. We're constantly improving our system. I think so. You're going to see slight changes over time, but there's no kind of one moment in time where I can say before this data was of one quality and after this so of another quality. Certainly, if you're looking at the Open Data Archive and you have questions or something doesn't seem right about the data, we'd appreciate if you reach out. We can always reprocess the data and take a closer look for you.
All right, thank you. I think I have it's a question here. So let's see, give me a second. It might take me a second. Let's see. If you could, I think I missed a question regarding the quality of the archive, but I do need to send that question, Forrest. So give me just a second on that. And in the meantime, I am going to jump to the next question here. All right. Are your satellites looking along track, left looking, right looking? What is your highest latitudinal limit for imaging? Try to find.
I can take this question. So our satellites aren't restricted to looking left or right. We can look in either direction to image. Our satellites can also squint fairly far forward, about 60 degrees off broadside, both forward and backwards to image as well. So depending on what type of tasking a user needs specifically, we might change or restrict or the squint or squint angles that are used. As far as the highest latitudinal limit for imaging, I've taken images of the North Pole and the South Pole, so I don't think there are any. We do have less feasibility at the northern poles because that's where nearby one of our main ground stations that we utilize for downlinking data.
Okay, thank you, Chris. I am still trying to find that question that I've overlooked here. All right, so I don't think we have responded to this question yet. How closely does the Spotlight Scene Center align with the specified tasking input point?
I can answer this question. So for our spotlight modes, there is significant inaccuracy that will just be variable upon the pointing accuracy of our system itself, which usually is going to be within a handful of meters. When we do more of our dynamic strip map tasking, there is some consideration that goes into that allows us for improved radar parameters to allow for opportunities to be improved in how the radar is tasked. That may vary off of the given ground track that is desired.
Okay, thank you, Eric. So the next question here is, do you generally only acquire on customer request, or are you proactively building archive imagery for likely locations of interest? Historical data can be of particular interest for looking at change, but having the before image is important.
Well, I would say a little bit of both. We do take user input on social media. I believe earlier this year we had a Google document. If you had an area on Earth you wanted us to image, we would image it and put that imagery right into our open archive or into the Open Data Program. But then we do heavily rely on our customers and then some proactivity amongst Umbrans here to image different areas on Earth. But we're always open to suggestions of areas that users might want us to image for inclusion in both our paid archive repository and our open data repository.
Perfect. Thank you so much. Appreciate that. For the next question, actually a question for me. Is there somewhere I can access the links after the webinar? And although I typed in a response, I'm going to mention it again just for the benefit of everybody. And so I can paste the links to the presentation slide decks in the chat. I will send a follow-up thank you message to all webinar registrants and participants that include both links to the presentation slide decks that were presented today, as well as a link to the recording for this afternoon session. There is some post-processing involved, and it's a process that goes through another team. So it usually takes me, I should say multiple teams, my team and another team. And so it'll probably take a few days, but you should expect that if not by the end of this week, by early next week. So I hope that helps a bit. And let me, with that, move down to the next question. I haven't responded to that one. Okay. The next question is, thank you, Krishna. Are there open source workflows available for Umbra SAR pre-processing, radiometric calibration, and terrain correction?
So I don't know of any open source projects or workflows that reference Umbra data specifically necessarily, but I know a lot of our users utilize SARPy for reading in our imagery, doing their own data product generation from all the way from our CPHDs to SICIDs, SIDs, and that kind of thing. It's a good question though, and now I'm curious what kind of open source workflows are out there that I don't know about.
Well, thanks so much, Chris. Appreciate that. So the next question is, are lookup tables for incidence, angle, or impedance pattern corrections included? This will help for radiometric calibration, which is kind of building upon the question I just asked.
I can take this one. So in our SICID data products or our complex image data, we do have we fill in the antenna polynomials within the metadata that is requested by the SICID standard. That can be applied to the data as far as our detected image products such as GeoTIFFs or the SID, which is once again our DoD government standard. We have applied the antenna polynomial correction to our data already, and that should be removed and should not have a factor on calibration of our effects.
All right. Perfect. Thank you, Eric, for your response there. Our next question here, and just for everybody's benefit, we are currently in the extended Q&A period, which will have a hard cutoff of 3:15 p.m. Eastern, so we'll get about 12 minutes left. The next question is, are there any application areas that stand out as coming into their prime by having access to sub-meter resolution SAR?
I could take that. One of them that I've seen a lot of lately, and we're getting more and more requests from the folks like USGS and then our researcher friends in New Zealand, are the animal monitoring, especially in the polar regions where optical imagery is really only useful for half the year. Additionally, looking at areas in the tropics, rainforest monitoring, things of that sort are really we're seeing more of the research partners coming and asking us for sub-meter imagery over those type of problem sets.
All right. Well, thanks, Kyle. The next question is, how closely does the spotlight scene center align with the specified tasking input point?
I think we already answered that one. Eric had done that earlier.
All right. You see here. All right. For the next one is Just checking to see. Okay, I see that Dana has actually provided a response to this one, so bear with me for a moment if you would. Another one Dana has also. Okay, so the next question is, are there any new capabilities coming down the line to look forward to? InSAR compatible products would be great to have at some point.
Yeah, I can take this one. So we are really engaged at Umbra right now with planning to launch Umbra 11 and Umbra 12. New satellite launches, consume a lot of our activity here at Umbra, and then shortly after that, we have Umbra 13 and Umbra 14 launching. Some of our new products to look forward to actually are listed on our website. So you can go and look at some of our bistatic capabilities, expanding the reach of our dynamic Stripmap or scan mode product to do larger and larger areas. And there's some really interesting use cases in the maritime domain, which are really valuable for that product. And then we have a number of things coming out of our R&D team. I hope that you got from the other presenters that we are scientists and engineers here at Umbra. We are constantly trying to push the capabilities of what our satellites can do. Our existing orbits are not really compatible with InSAR, but we are looking at that as a capability from the orbital design in the future. So we totally understand the value to the SAR user community for InSAR type investigations. And that more is determined by how we put our satellites into orbit and how we collect with those satellites once they're there. But there's a lot of innovation happening, and you will continue to see that list of experimental products continue to grow on our website if you want to keep an eye on that.
All right. Thank you so much. Right. I do not see any further questions. So with that, I'd like to thank all of our speakers this afternoon and my backup host, as well as the subject matter experts from Umbra. But, most importantly, I really would like to thank all of you for taking time out of your day to join us and learn more about the Umbra capabilities. We really appreciate you, and we hope to see you at an upcoming webinar. All right, everybody. With that, we'll log off from the audio component, but I will leave the virtual meeting space open. All right. Thanks so much, everybody. All right. Take care now.